Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve d square minus d into y equals to x cos x. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order is 2 and highest power of the highest derivative is a degree is 1. Or just write the given differential equation as d square y minus dy equals to x cos x. We know that d is a differential operator. Then d square will be d square by dx square. We can write this equation as d square y by dx square minus dy by dx equals to x cos x. Here d square y by dx square is the highest derivative, so order will be 2 and highest power of the highest derivative is a degree is 1. Now coming to the problem. Given differential equation, d square minus d into y equals to x cos x, which is in operator form f of d into y equals to q, where f of d equals to d square minus d and q equals to x cos x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find complementary function using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. By putting RHS to 0, we'll get the homogeneous equation of the given non-homogeneous equation, right? And we'll find yp using 1 by f of d into q. So let's find yc and yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus d, right? Let's replace d by m, so that we'll get f of m equals to m square minus m. Now our auxiliary equation becomes m square minus m equals to 0. Now take m common from the two terms of LHS, we'll get m times m minus 1 equals to 0. Now equate each factor to 0, we'll get m equals to 0 and m minus 1 equals to 0. M equals to 0 is one root, and from m minus 1 equals to 0, we'll get m equals to 1. So the roots are m equals to 0 and 1, which are real and distinct, or we can call them as real and different. We know that when two roots are real and distinct, then yc will be one constant into e power 1 root into x plus another constant into e power another root into x. Now our complementary function will be yc equals to c1 e power 0 into x plus c2 e power 1 into x. Then yc will be c1 into e power 0 into x is e power 0 plus c2 e power 1 into x is x, right? Then yc becomes c1 into, we know that e power 0 is 1, right? Since e power 0 is 1, so we'll get c1 into 1 plus c2 into e power x, right? Therefore, yc equals to c1 into 1 is c1 plus c2 into e power x. Therefore, yc equals to c1 plus c2 e power x. We got yc, let's find yp. Particular integral we'll find particular integral using 1 by f of d into q. This is equals to 1 by f of d. We have d square minus d and q is x cos x. This of 1 by f of d into x into v form. So we are going to use x into 1 by f of d into v minus f dash of d by f of d whole square into v formula. Okay, if f of d is d square minus d, then f dash of d will be 2d minus 0, sorry, minus 1, right? Derivative of 2d with respect to d is 2d, and derivative of d square with respect to d is 2d minus derivative of d with respect to d is 1, right? Now, let's apply this formula. X into 1 by f of d into v, for v equals to cos x. Okay, here v is cos x minus f dash of d, 2d minus 1 by f of d whole square into v cos x. So this is of 1 by f of d into some cos ax form. Then for a equals to 1, we'll find d square, which is given by minus of a square, which is equals to minus. For a equals to 1, we'll get minus of 1 square equals to minus 1. If we replace d square by minus 1, the denominator becomes non-zero, right? Always the denominator must be non-zero. Okay, we have to keep that in mind. Now let's replace d square by minus 1 in both the terms. We'll get y becomes x into 1 by minus 1, just replace d square by minus 1 into cos x minus 2d minus 1 by, I'll just remove these brackets, okay, by minus 1 minus d whole square into cos x. This becomes x into 1 by, take minus common from these two terms, we'll get minus of or minus 1 common, okay, we'll get minus 1 of 1 plus d into cos x minus 2d minus 1 by, here also we'll take minus common in the denominator, we'll get minus 1 into 1 plus d, right, into cos x is equals to, here you're having, or you can just split this as 1 by minus 1 into 1 by 1 plus d cos x minus 2d minus 1 by minus 1 whole square into 1 plus d whole square. Right, this equals to x into 1 by minus 1 is obviously minus 1. X into minus 1 into 1 by 1 plus d. In the denominator of this fraction we are having plus, right? So just replace this plus with minus, we'll get 1 minus d. Now multiply and divide 1 minus d to this fraction, we'll get, right, 1 by 1 plus d into 1 minus d by 1 minus d into cos x minus 2d minus 1 by minus 1 whole square is 1 into 1 plus d whole square. Let's expand 1 plus d whole square, we'll get 1 plus d square plus 2d into cos x. So this becomes minus x, x into minus 1 is minus x into 1 into 1 minus d is 1 minus d by 1 plus d into 1 minus d into cos x minus, here d square appears in the denominator, so let's replace d square by minus 1. We'll get, obviously by replacing d square by minus 1, the denominator will be non-zero because we are having plus 2d here, right? Only 1 and minus 1 gets cancelled and we'll get non-zero term. If we get a 0, if the denominator becomes 0, we'll get 2d by 0 into cos x, okay? This term becomes 2d minus 1 by 0 into cos x. Since anything by 0 is undefined, so total term becomes undefined. So always remember that the denominator must be non-zero. But in our case, by replacing d square, we'll get non-zero term in the denominator. Okay, just replace d square by minus 1 only in the second term, because in the first term we don't have any d square, right? So let's replace d square by minus 1. We'll get 1 minus 1 plus 2d into cos x. This becomes minus x into 1 minus d by, the denominator is of a plus b into a minus b form, so we can write it as a square minus b square into cos x minus 2d minus 1 by, here plus 1 minus 1 gets cancelled and we'll get 2d into cos x. So this becomes minus x into 1 minus d by, 1 square is 1 minus d square into cos x minus, see here in this fraction we have two terms in the numerator and one term in the denominator, so we can split the whole fraction as two fractions, 2d by 2d minus 1 by 2d into cos x is equals to minus x into 1 minus d by, again d square appears in the first term, so let's replace d square by minus 1. See what happens if we replace d square by minus 1 in the denominator. I'm just taking the denominator part, 1 minus d square, and see what happens if we replace d square by minus 1. We'll get 1 minus of minus 1, which is 1 plus 1 is 2, which is non-zero, right? So we can replace d square by minus 1 in the first term, right? We'll get 1 minus of minus 1 into cos x minus of 2d by 2d is 1 minus 1 by 2d into cos x. This equals to minus x into 1 minus d by 1 minus into minus plus 1 into cos x minus 1 into cos x is cos x minus into minus plus 1 by 2d into cos x is 1 by 2d cos x is equals to minus x into 1 minus d by 2 into cos x minus cos x plus, we can split 1 by 2d as 1 by 2 into 1 by d, right? Here 1 by d is an integral operator, so we need to find integral cos x here. This becomes minus x into, split this fraction as 1 by 2 into 1 minus d into cos x minus cos x plus 1 by 2 into, here we need to find integral cos x dx is equals to minus x into 1 by 2 is minus x by 2 into 1 into cos x is cos x minus d cos x minus cos x plus 1 by 2 into integral cos x dx is sin x is equals to minus x by 2 into cos x minus, we know that d is a differential operator. So now we need to find, in the next step, we are going to find derivative of cos x with respect to x minus cos x plus 1 by 2 sin x is equals to minus x by 2 into cos x minus derivative of cos x with respect to x is minus sin x. So now just write these two as it is equals to minus x by 2 into cos x minus into minus plus sin x. Now take take LCM of these two terms, we'll get, or just take minus 1 by 2 common from these two terms. or take 1 by 2 common, better 1 by 2 common from these two terms, since the second for, okay, this term does not has any 1 by 2. So what we'll do is we'll just multiply and divide 2 and take 1 by 2 common from these two terms. Okay, we'll get, better take minus 1 by 2 common from these two terms, and we'll get minus 1 by 2 into 2 cos x minus sin x. See, 1 by 2 into 2 cos x is minus 2 by 2 cos x, minus into minus plus, 1 by 2 into sin x is 1 by 2 sin x, right? Also we can write this as minus x by 2 into cos x plus sin x minus 1 by 2 into 2 cos x minus sin x. We got yc and yp. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 plus c2 e power x, and yp is minus x by 2 cos x plus sin x minus 1 by 2 into 2 cos x minus sin x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.